Hello everyone, it's me, Witch Calypso again with Bubbles, and we're here for another RPG Maker tutorial video. Today we're going to be doing a little, at first I thought this was like, oh, Simon Says. It's like, well, not exactly. So, memory game is the more proper, I believe what this is called. If you know, like, what this is called, if it's not, if it is actually called Simon Says, then let me know, but I'm just gonna call it a memory game. So we hit that orb and it starts the sequence. So it was yellow, now yellow, green, now yellow, green, and yellow again. Awesome. And we did it. And there we go, we get a little reward there. Hooray, if I can open it. Alright, I'm going to show you a little bit more about that later, but for now, let's look more into the code for what we have. So we have 3 common events, and if you're wondering how many variables do we work with on this one, only 1, just 1. Let me show you how this works. So the important thing is that this is, I know I said this is going to be a more simple one from last week, and technically this is simple, maybe. So I have 1 variable that is an array. And technically it does have an array within it, so it is a multi-dimensional array, but it's only for 1 index of the array, so it's still relatively simple. What we're doing here, or what I did here, is I basically set up a system so it's easy for you to use this multiple times in your game, and at the same time being able to easily adjust it. So that way all you have to do is set up this variable with the proper inputs, and then the game should do, or the software, the code should take that input and then give you an output for it. So I have a comment here that basically tells me what each index is related to. Index 0 is the input. We'll get more into that later. 1 is the sequence count, 2 is the current count, 3 is for final count, 4 is for map ID, 5 is for the starting event, 6 is for the event count, 7 for default time, 8 for time reduce, and 9 for the actual code, the sequence code. So let me go into, let's show the generation, so we can kind of give you a little bit more context as like what each one of those means. So the very first thing that we want to do whenever we call memory game gen is that we want to do game variables value of 0, which game variable 17 square brackets 0, which once again, this is basically calling the first index of the array. So 0 is just input. We're going to set that to 0, and then we do this dot weight 60. This right here, this dot weight and the number is the same thing as going into here and doing timing and then just setting it to like 60 frames, which is like 1 second. This and this are the same. Once again, the main difference is that this lets us edit a little bit more. But for now, that's just kind of basic. We want to give the game a second to kind of like ready up. And then I'm going to skip this loop for now. We'll come back to it. Let's go down here. So we have some temp variables here that are being related to different indexes of our array. So map equals game variables value of 17, 4. Remember, again, in that setup we're doing, 4 is the map ID. Event is related to 5. Oh, and of course, you know, map ID just means like what map are you on? Which if you don't know how to figure that out, if you look at the bottom of the screen, you probably can't see, it's really small, but on the bottom around here, it should say the ID of the map you're on. You can also just like go to your map and then edit it. And then right there, up here in the upper left-hand corner, it says ID and then whatever number it is. In this case, it's 6. So that's to let you know that this ID for this map is 6. So that's how you find that information. Event for 5. This is basically to tell the game what's the starting event for our sequences. For the objects that we're using to basically visually tell the player, like, you know, red, blue, green, whatever, whether you're using crystals or orbs or switches or whatever, right? Because when you're setting this up, the number one thing you want to do is you want to make sure that these events are in order, or at least next to each other. So 1, 2, if you see over here, it's like 1, 2, 3, and 4. And then the one after all that is the event that you're using to kind of start off everything. But you want to make sure that these are like next to each other. I'll explain more on that later. Count is related to variable 6, or index 6 of the variable, which is the event count. This is basically just telling the game, or the software, the code, how many events you have in your group. So right now, I have it set to this index equals 4, because I have 4 different crystals that we're using for the memory. So the green crystal, blue crystal, yellow crystal, green crystal. If you wanted there to be more, then you would adjust that number. If you wanted there to be 5 crystals or 6 crystals or 7 crystals, then you would change that number to correlate to how many there are that can potentially be used in the combination. And once again, sorry, starting event is, the starting event here is obviously where it starts. So for me, this is easy, it's just 1, but if you're like doing other stuff on the map and you get to the part where you're like, oh, I want to do the Simon Says memory game sequence, and it's not at 1, then you would just change that number. You would change in your array here, you would change this number from 1 to wherever it's starting. Okay, now we go here, and now game variables value of 17, 0, which once again 0 is input. We're gonna set equal to math.random, which this is basically just RNG, equal to count, which once again count is basically saying how many variables or how many crystals, so to say, that we have for our code. And then we do plus event, which once again, remember, event is where we're telling it where it starts. So in this case, this is basically saying, give me a random number between count, which is 4. So it gives me a number between 0, 1, 2, or 3. And then it'll add the event to that number. So in this case, it adds 1. So if it gives me a 0, it gives me 1. If it gives me a 1, it gives me 2, 2, 3, and 3 and 4, right? Which correlates to our 4 crystals here. And we do it this way so that it can be modular. It can adapt to whatever we're giving it. So if, let's say that we don't start this until like event 5, as long as we're telling it that the starting event is 5, and there once again are 4 crystals, it'll then do math.random count, which would give us 5 crystals, right? So 0 to 4. And so if event is starting at 5, then it'll be 5, 6, 7, 8, 9, exactly, right? So it adapts itself. And then input, we set input equal to game variables value of 17, 0. Basically just, you know, we're doing this just to make it so that when we put it in here, it's like less writing. You don't have to do this stuff if you don't want to. I just do it because it makes it easier. So now we do game self switches.set value, and we do map, which once again, map is basically telling us what ID the map is on. Input is once again telling us which crystal we want to turn on, and then we want to turn self switch A of that crystal to true or on. And then game variables.value of 17.9, which once again is the code. We want to push that input into it. So if it turned crystal 1 on, then we want to push that 1 into the code. Oh, sorry, my allergies are bothering me today. Audio manager.play sound effect, and then, you know, this is, once again, I have the link in the description below to the general callouts that you can do in RPG Maker MV and MZ. So this is basically just play the sound effect. Okay, and then We'll explain more about the scale here in a bit. We'll get back to this, but for now, let's just focus on this code right here. This dot wait, and then game variables dot value 17.7, which once again, that is the default time, and I believe I have set to 30, so 30 frames or half a second. And then don't worry about my scale. We'll get back to that later. But we're just doing this so that the game has some time to pause, to turn the crystal on, pause, and then it'll turn the crystal off in this code right here. And another little note here, whenever you're doing this dot wait, you have to make sure it's in a completely different script call. If you try and put this dot wait in like the same script here, it's going to do it, but it won't do it. It won't wait until after it's done running all the code in that script. So you have to separate them. And then once it's done waiting, it does its pause. It goes here. Once again, we just tell it map equals variable 4, input equals 0, and then game self switches dot set value, map input a, turn it off. So right here, this code right here is basically just telling us, or telling the game, turn a random crystal on and then turn it back off, so the player has a visual as to what the first code of the combination is. And we push that number into the 9th index of our array, which is saving that code. And then once again, we just do another pause down here. Now let's go back up here for this loop. This loop is just saying, right here, I have it in a script call for an if statement. If game variable, value of 0, so our input, if it is equal to the length of the code, then break the loop, break out of the for loop. So the first time that goes through this, obviously the length of the code is 0, so because input is 0 and the code length is 0, it just immediately breaks out of this loop, doesn't do anything. But if the player gets the code right, then we want to add more to it. So now the length of the array, because we pushed like 1 into it, now the length of the array is 1. So now this does not equal, so it doesn't break out the loop. So it's going to come here, and it's going to basically do the same code. The only difference is that now we want to tell it to regurgitate or repeat the code that we've already established. So we do the same thing. We establish that map event code input. We do all the same stuff here, and then we just tell it once again, game self switches dot value of map code. This is the difference. Instead of just saying input, we want to do code, which is, once again, equals the array that we're setting up, the nested array that we're doing. We want to say code input, and then set that to true. Once again, audio manager is here. And then we do the same. This is the exact same code, just wait a little bit before you turn it back off. Once again, just telling it, hey, okay, turn it off. And then we tell game variable 0, 17.0, index 0, we want to add 1 to it, which will then increment it up, and now it goes back up to the top of the loop, and now it's like, oh, it's 1 and the length of the array is 1. And so it breaks out of the loop. And then it comes down here and it does what we just did before, where it's now going to get a random input and then add that input into the array. And so every time that you get the correct code, it's going to regurgitate. It does this code right here, where it regurgitates what we already know, the code for the memory game. And then once it's done doing that, it adds an extra input or an extra code to the combination. Now let's go to memory game check. So this is what we're using to basically check and see if the player did the right combination. So this common event is basically just being put inside each memory crystal. And whenever it gets turned on, there's nothing in here because we don't, it turns on, then it turns off. We don't need to do anything about that. But it does memory game check here. The only thing that is inside the starting crystal is simply just this, which is saying if game variables dot value of 17.9 or the code equals 0, then you can go ahead and play magic, set up the array, and then run common event memory game gen, which is what I just went over. This is to make it so that if you're in a game, it will not, it won't run this again because you're already playing a game. And the same thing here, memory game check, I have it here in the common event. Memory game check is saying if the same thing, if the code does not equal 0. So if you're not playing a game, it won't run this code. But if you did start it and you are playing a game, then it will run this code if you interact with the crystal. So once again, we're going to change a little bit how input works, because input is not randomized now. The input is what we are telling the game the input to be. We are clicking on one of the crystals and telling the input that. So we say input is going to equal this dot event ID, and this is basically just telling the game whatever common event this is being run in, get the ID of it. So once again, this is to make it very modular and it's easier to work with. So because, like, for example, if we're doing the memory check in this crystal, it'll get this ID code of this crystal, which is 1, and it'll store that into input. And then same thing here, map and code are what we've already established. We're just setting those up again, because every time that you do a new one of these script calls, you have to reestablish those. You don't have to if you like. If you just put game variables.value 17.4 in here where map is, and then input here, or well, input doesn't get moved around, but oh, I don't even need this here. I just realized I don't even need that there. That's fine. But if you just put this information in right here, then you technically don't need to do this. I just do it because it's less typing and it makes this chunk of code shorter. It's however you want to do it. It's up to you. Okay. And then we tell it to wait 10 frames. This one, this is basically telling the game how long it's going to wait before it turns off your input. Like the crystal you touch turns on for a little bit, then turns back off. I set it to 10 frames. That's like feels about right. We honestly don't want it to wait too long, because we kind of want it to be a little bit more snappy when the player's inputting the code. And I feel like 10 frames is like a good amount of time to wait. You can edit this to your liking. And then we come down here, and once again, we're going to do input equals this event.id, or this dot event ID, map equals that, code equals this, you know, what we've already established. Game soft switches set value of mat input A, false, turn the crystal off. And then we go here, we have if input equals code of game variables.value 17.1, which is the sequence count, basically telling the game like what stage of the code you're on. So right now sequence code equals 0, so it's going to compare the first index of the code equal to what we just inputted. So if the first crystal, the yellow crystal, turned on, then in the code is 1. And so if we press the 1 crystal, or if we press the yellow crystal, it's going to send the event ID, which is 1, into input. So 1 should equal 1, which is like, oh, it's correct. So now we just tell it to increase the sequence count by 1, saying that you got it right. If you didn't get it right, then we play a buzzer sound effect, and we tell it to empty out the array of the nested array in the main array. We just tell it to empty it out because you didn't get it right, so reset the puzzle, which makes it so that, once again, because this is empty, you cannot interact with the crystals, but you can't interact with the starting, the main orb that's like starts off the code. So now we have this down here. If game variables value of 17.1, which is the sequence that we're on, if it equals code.length, if it equals code.length, then basically that means that you did it. That means that you did it and you have finished the current sequence. So obviously the first time you do it, it's just like the first crystal you touch, but essentially this is just saying, okay, you got it right up to the final input, right? So if there's like 5 sequences that we're working with of the code, once we get to the 5th sequence, it's like, okay, you're done, you did it, you completed the current combination. We set game variable 17.1, the sequence count back to 0. We say game variable 17.2, which once again, that is the current count that you're on. We increment that up by 1. And then we say if code.length equals game variable's value of 17.3, which if you remember correctly, game variable's value of 17.3, this is the final count. This is how long we want the player to play this game before they fully complete the minigame. So for the one I just showed you guys, this is 3. So once you've done 3 sequences of the code, then you are good. It does audio manager, plays item, ME, which, I mean, the code for playing a sound effect and then playing like the music effect, I think that's what it stands for. It's the same, you just change the S to an M, and it's the exact same code regardless. And then we say this dot command 117.12. This is basically call common event. This dot command 117 is what you need to tell the game to do common event flow control. That's basically all this is doing. So if you have finished the entire combination, or if you've gotten to the final count, then it plays this dot command 17 of common event 12, which we'll get to later. But otherwise, we say, okay, you're not done yet. You still have a little bit more work to do. So then we just tell it to recall common event 10, which is the memory game generation, which once again is this code right here, which is just regurgitating the code that we did and then adding a new code to the sequence. When we do memory game clear, we are emptying out the code, the array. So 17 index 9, we empty it out. We tell it to wait a little bit. We tell it to wait because it's playing a jingle, so give it a little bit of time. I did it for 90 frames, which is like a second and a half. So just wait, give it a little bit of wait. You can adjust that to your liking. And then I flash the screen, we play sync 4, just a sound effect. And then once again, we establish map, event, and then count equal to their correlation to the main array. And then we say for x equals 0, as long as x is less than count, which once again, count, which is index 6 of the array, is our event count. So basically telling the game how many, in this case, crystals we have that can potentially be used for the sequence. Is going to go through each one of those and set that value of that common event, of that event, the self switch B to true. Which, if I show you here, if you set B to true, it just brings it over here. And this is like a clear crystal, so you can't interact with it anymore. It's just there to tell the player, hey, you beat this puzzle, good job. It is done. And so this right here is just doing a for loop, so it goes through every single one of them to make them all turn to B, and thus be no more you can interact with it. And also, we have event equals 5, and then down here we have event plus x. Once again, it's the same thing that we're doing before. We're just saying, because x equals 0, and we're saying that event starts at 1. So, okay, gotcha. So 1, and then it'll be 1 plus 1, which is 2, then 3, then 4. And we tell it to go until count plus 1. We're doing count plus 1 because we want to include the game start orb here. Because whenever you're done with it, we obviously want to reward the player for doing a good job. So we tell it to turn on self switch B. Technically self switch A is not being used, but I'm just doing B here because it makes it so that this can just use B. So it's just more convenient that way. So yeah, it calls B, goes here, turns B on, turns to a chest, and then, you know, this is the standard open chest code. And then it turns event switch C on, which means you got the thing out of the chest and you're good. Put it up. And that's the code. But to show you a little bit about how this is easy to adjust, and let me go ahead and show you a little bit more. Let me show you the other version of this I created. So we have this one, you already saw it. But I made this one over here, which is now has 5 crystals in the combination. So if I interact with this crystal, it shows red. Now, another thing that I added for this version is that if you remember on the wait function, the wait script, where it waits between turning the crystal off and going to the next sequence, I included a timer reduce in a default time. Default time is just saying how long we want it to wait between each frame, which I believe I set to 30, so half a second between each new sequence of the code. Timer reduced is if you want to make the game a little bit more difficult. You want it to speed up as the player gets more and more of the combination right. So this one has that, and I set it to 5 so that every time that you get a combination right, it's going to reduce that default time of 30 frames by 5 frames. So this will get quicker as we go through it. Okay, red, yellow, blue. Red, yellow, blue, red. There we go. And see, it properly adapted itself because there are 5 events in it, so it did everything that it needed to do. We got the treasure chest, open it, probably want to get more silver, but you see what I'm doing here. So let me go through that code now that I showed you that. And once again, as you can see here, in this event, I set control variables, and I said, now input, sequence count, and current count, the first 3 variables here, or first 3 indexes here, those will always be 0. Those are not going to change. When you get the final count here, once again, final count is just how long you want the player to go before they finish the minigame. This is 3. You can make it as large as you want it to be. So 5, 7, 10, it'll do what it needs to do until it gets there. The next one here, which I said is 6, this is the map ID. 1 here is the starting event, which is 1. 4 here is the event count. There are 4 memory crystals, so we say 4. Default time is 30. So that's how long the game's going to wait between each new edition of the code when it's generating the code. And then this one I want to keep it easy, so he said 0. It does not speed up at all as you progress through the sequence. And then the array here is always going to be empty every time. But if we go over to Memory Game 2, I edited this code, or this one. So now, instead of it being 3, you have to beat 5. You have to go through 5 sequences before you complete the minigame. This is 7, because now the map is 7, and the starting code, or the starting memory crystal is at 2, as you see over here. Because I have, like right here, I said, oh, well, I made the first event transfer so I can get back to the previous map. So now it's not 1 anymore. The starting crystal is at 2. So now we just need to tell the game that. We just say, okay, well, it's 2. And then, per usual, make sure that as long as these are in order and they're next to each other, this will work. So we're just telling it, start at 2, and then there are 5 memory crystals. So this is, instead of this being a 4, this is now a 5. And then I still kept this as 30. Once again, you can adjust this as however you want it to be. But this time, instead of this being a 0, it is now a 5. Because I want it, every time you get the sequence correct, I want this to reduce it by 5 every time. So at first there'll be 30, then 25, then 20, then 15, 10, 5, right? It'll get quicker and quicker. Now, one thing you want to be careful about, to go back to this code, is that if you don't want this to hit 0, you don't want the wait time between each new input of the sequence to be 0, because then the player literally has no time to see what happened, and that's not fair. So we just have an if statement here, and we have scale. Scale equals game variables value 17.2, which remember 2 is the current count. This is basically telling the game how many sequences you've gotten correct so far. So if you're on the second one, then it's like, okay, 2. And then it does 2 times game variables value of 17.8, which 8, once again, is our timer reducer, which in my example is 5. So this basically just amplifies it. So the first time you get it right, the first time you get the sequence right, it's now 5. And then that next one will go to a 2. Then it'll be 2 times 5, which is 10, 15, 20, etc., etc. Now, this if statement is just a safeguard. So if scale is ever greater than or equal to game variables.value of 17.7, which 7, the 7th index, is our default time. If scale is ever greater than or equal to the default time, then we're going to tell it just set this dot wait 5. Just wait 5 frames. Because I feel like 5 frames is very quick, but it should still be like reasonably readable to the human eye. Once again, you can set this however you want, depending on how difficult you want it to be. Otherwise, we just tell it to say this dot wait game variables of 17.7, which is the default time, minus the scale. So it starts off at 30, and it'll be 30 minus 5, 30 minus 10, 30 minus 15, etc., etc. And there you go. And that is how you basically make a memory game. And once again, if you wanted to add more to this, you could. As long as you update the input here. Oh, and then of course, sorry, one final thing. Make sure, like with every, like I mentioned this before in a previous tutorial, make sure that you have a common event or a call that kind of establishes everything. This right here, we're just saying set this memory game variable 17 to be this, and then turn cell switch A on, and then, you know, it's off, it never gets run again. We have to establish this from the beginning, because if we don't, this code, game variables.value of length, variable 17.9 length, it won't know what this means because we haven't established it yet, so it won't be able to read and you'll get a crash. So you just want to make sure you establish this array from the get-go. And this, as long as you do that, then you're all good. All you have to do is just make sure you set up this variable to be whatever you want it to be, and then call common event memory game gen, and you're good. So as one final little send off, let's go ahead and make this one like incredibly difficult, so you guys see how bad my memory is. So we're gonna set this to be 10, which once again, we don't have to worry about it. If it ever gets to be less than 30, which it will if we're doing 5, it'll catch itself at 5. So let's go here. So now it's gonna speed up really fast, really fast, really quick. Red, yellow, red, yellow, red, yellow, red, yellow. Red, yellow, red, yellow, red. Okay, I got very lucky there. I got very lucky that the combination was very simple. But yeah, I think, once again, you can adjust that. I think 5 is like a good number of, like, it's really quick and very difficult, but it should still be relatively readable to the human eye. So, but yeah, that's all I have for today. And once again, if there's anything you all want to, if you have any questions, any comments, concerns, suggestions, things that you want me to explain more in detail, or maybe add more to what I already have, just let me know. But I hope this helps. Thanks again for watching, and I'll see you guys next week. You have a good one. Bye!